Today we're covering constants and shadowing in Rust. Imagine this. You're writing a program, and you need to store a value that should never change. Maybe the speed of light, a tax rate, or the maximum number of connections in a web server. You set it as a variable, but then, somewhere else in your code, you accidentally modify it. But what if I told you that Rust has a built-in way to prevent this? We're going to break it down with some code examples. So grab your keyboards, open your Rust playground, and let's dive in. All right, let's start with constants in Rust. These are values that never change, ever. Even if you wanted to modify them, Rust won't let you. Here's how you define a constant in Rust. See that? We use the const keyword, followed by the name of our constant, a type annotation, u32 in this case, and then assign it a value. Rust enforces two strict rules for constants. They must have a type annotation. They cannot be assigned a value that changes at runtime. For example, if I try to do this, Rust throws a compile time error because getMaxUsers is a function call, which happens at runtime. Constants must be assigned a value that is known at compile time. Now, you might be wondering, what about static variables? Aren't they also constants? Well, kind of. But there's a key difference. Static variables have a fixed memory address and live for the entire duration of the program. They're useful when you need global, long-lived values. Let's see an example. Here, welcome message is stored in a fixed memory location and stays there as long as the program is running. Now, here's where things get interesting. Static variables can sometimes be mutable, unlike constant. But there's a catch. You need unsafe blocks. Watch this. Notice how we had to wrap the modification in an unsafe block? That's because Rust doesn't enforce borrow checking rules on static mutable variables, which can lead to data races in multi-threaded programs. So, if you don't need global mutability, stick with const. All right, now let's talk about shadowing, one of Rust's coolest features. Normally, when you declare a variable with let, it's immutable by default. But what if you need to modify its value? You could use mutable, but Rust has a more interesting way. Shadowing. Let's take a look at this simple example. Whoa, did you catch that? We redeclared x using let again. But instead of modifying the original value, Rust creates a new variable that shadows the old one. This means the old x is no longer accessible, and the new x takes its place. Now, you might be wondering, why would I use shadowing instead of mutable? Great question. Here are two big advantages of shadowing. Type changes are allowed. Unlike mutable, shadowing lets us change types in the same scope. Scope transformations. We can transform a variable without making it mutable. Let's see both in action. See, the first spaces was a string, and then we shadowed it with spaces.len, which is a number. This wouldn't be possible with mutable. And here's another cool use case. Let's say you want to transform user input without modifying the original value. Shadowing makes it super clean. If we use shadowing like this, there is no need for an extra variable. The input string gets shadowed by its parsed integer version, making our code cleaner. Shadowing is great for transformations, and since we're reusing the same name, it keeps our code more readable. Now, here's your challenge. Try modifying today's code examples. See if you can break Rust's borrow checker with static mutable, or experiment with shadowing.